Hello there, students. This video is an enrichment lesson on analyzing resistors in series parallel combinations. So just hang on, watch and learn. Here's the question. As shown in the diagram, 5 resistors R1 equals 7.0 ohm, R2 11 ohms, R3 and R4 each has a resistance of 4.0 ohms and an unknown resistance R5 are wired to an ideal battery of EMF epsilon equal to 30 volts. If the voltage across the first resistor is 24 volts, find the resistance of the fifth resistor R5. Alright, so this is what we're going to do as we answer this question. We have to combine the resistances that are directly in series to each other and those that are directly in parallel to each other. For instance, we have the resistors R2 and R3 are considered in parallel to each other. So if you're going to get their sum or their combined resistance, denoted here by R sub 23. Alright? So since they're parallel, we usually use the reciprocal formula, but here I'm going to use the shortcut formula in determining the combined resistance of two given resistors that are connected in parallel to each other. Alright? So it's like this. You just multiply the two given resistances, such as R2 times R3, and then divide this by the sum of the two resistances, R2 plus R3. Next, we have also the resistor R4 in series to R5. So if you're going to combine them and get their sum, we will label it as R sub 45. And since they're in series, we just add R4 plus R5 directly. Alright? Now, the moment R4 and R5 are already combined, meaning R45 is now the sum of R4 and R5. Okay? That happens to be, alright, when you substitute, since we're given already the values for R4, that is 4.0 ohm, and the unknown resistor or resistance R5. Alright, so this combined resistance R45, alright, happens to be in parallel to the combination of R2 and R3, which we label here as R23. So in order to add them up, alright, since they are parallel, again, we use the product over sum equation. We will label the sum of the resistors from R2 to R5. Alright, actually, this means the combination of R2, R3, R4, and R5. Alright, but we just use the shortcut notation R sub 2 to 5. So, we say it's the uh, product over the sum, right? The combined resistance of R2 and R3, right, to be multiplied to the combined resistance of R4 and R5, all right? And then we divide it by their sum. That means R23 plus R45. Then, after getting the combined resistance from R2 to R5, it will be added to R1, right? And R25 happens to be in series to R1, right? So, to get the total resistance denoted here by R sub t, we just add the two combined resistances R2 to 5 plus R1 since they are in series. And once we're able to get uh, the expression for RT, we can also make use of Ohm's law's equation, all right? The EMF epsilon is just equal to the product of the total resistance and the total current. But in this circuit diagram, the total current is actually the same as the current passing through R1, since R1, all right, is directly in series to the battery. So we can also say that the EMF epsilon is also the product of the total resistance R sub t and the current I sub 1. Since our target variable is R sub t, then we just use the expression R sub t is equal to epsilon divided by I sub 1. Before we have the detailed solution, we have here the summary of the given data. The EMF epsilon is equal to 30 volts. The voltage across resistor 1 is 24 volts. Uh, Resistance R1 is 7.0 ohm. Resistance 2 is 11 ohms. Resistance 3 and resistance 4 are the same, 4.0 ohm. And our target variable is resistance number 5. It should be noted that the current through the first resistor or I sub 1 can easily be determined using Ohm's law. 24 volts divided by 7.0 ohms, and the current passing through R1 therefore is equal to 3.4 amperes. And if you notice, resistance number 1 is directly in series to the battery. So whatever is the total current generated by this battery, we call it the total current, that must be equal to I sub 1 as well. So we start with combining R2 and R3. Since they are parallel, we are using the formula product over sum. That is 11 ohms multiplied by 4.0 ohm to be divided by their sum, which is 15 ohms. So we get the combined resistance of R2 and R3 equal to 2.9 ohms. R4 and R5 are directly in series, so we just add them directly, R4 plus R5. R4 is 4.0 ohm and R5 is still to be determined. Alright, R23 and R45 actually are connected in parallel. So to get their combination or their sum, which we will call R2, 3, 4, 5, again we use the product over sum formula. That is 2.9 ohms times 4.0 ohm plus R5, and then divided by their sum, which is 6.9 ohm plus R5. 4.0 ohm, when added to 2.9 ohm, that's 6.9 ohm. Of course, there's the plus R5. Now, this combined resistance for R2, R3, R4, and R5 is actually in series to R1. All right? But before getting the overall combination of the resistances, okay, we simplify this R2, 3, 4, 5 by multiplying 2.9 by 4.0, and we get 11.6 ohm squared. And then 2.9 times R5, of course, is 2.9 ohm R5, okay, divided by 6.9 ohm plus R5. And I was saying that R2, 3, 4, 5 is in series to R1. So if these two resistances, R2, 3, 4, 5, and R1, are combined, okay, their sum is actually the overall resistance in the whole circuit, denoted here by capital R sub T. All right? So we simply add R1, which is 7.0 ohm, by R2, 3, 4, 5. All right? That is 11.6 ohm squared plus 2.9 ohm R5, and divided by 6.9 ohm plus R5. Moving on with our solution. All right? So this equation for determining the total R, okay, with R5 still to be determined as well. We take note that the total current is equal to I sub 1, which is 3.4 amperes computed earlier. Now, this is the total current IT is related to the EMF. All right, we're talking about an ideal battery with negligible internal resistance. So the EMF in the battery can just be equated to the product of the total current IT and the total resistance R sub T. That means 3.4 amperes multiplied by RT. Alright? So, we can now equate RT, alright, to the EMF, of course, by multiplying RT by 3.4 amperes. And that is shown in this step. Right? So, uh, there is a need for us to isolate R5. Alright? But before we can do that, we first have to multiply 3.4 by 7 and then subtract that from 30 volts. Okay? That will be equal to 6.2. 3.4 times 7.0, okay? The product will be transferred to the left side of the equation, meaning to be deducted from 30 volts, and the result is 6.2. So we are only left with 3.4 to be multiplied to the whole quantities inside this parenthesis. All right. Then, uh, since there is a what we call denominator, in other words, the right side of the equation, okay, is fractional. The best way to simplify this is to cross multiply 6.9 ohm plus R5 to 6.2. All right. And we will be left with 3.4 multiplied to 11.6 plus 2.9 R5 on the right side of the equation. 6.2 times 6.9 will give you 42.8, and 6.2 times R5, of course, is plus 6.2 R5. So on the right side of the equation, multiplying 3.4 by 11.6 gives us 39.4, and then plus 3.4 times 2.9 R5, which is 9.9 R5. Okay. For simplicity, okay, we're doing away with the units, all right, for convenience. So from here, we can transfer 39.4 to the left side, meaning 42.8 minus 39.4, and 6.2 R5. When transferred to the right side, we will be getting 9.9 R5 minus 6.2 R5, or simply 3.4 equated to 3.7 R5. So, isolating R5, we will now divide 3.4 volts divided by 3.7 amperes. And our value for R5, the resistance of resistor number 5, equal to 0.92 ohms. Alright, so this is the answer to the question, and we are done with our tutorial. Thank you very much for your indulgence. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.